There you are, Fredrik.
Cool. So I'll try to do this as a presentation. Can everyone hear me? Someone?
Yes, I hear you fine.
Cool. So here to talk about Ozmoo, which is Z-code interpreter, and this is a screenshot of Ozmoo in action. And I'll let you in on what exactly is a Z-code interpreter. So I get this thumbnail. Guess you get it too as well. Yeah. Okay. So Ozmoo, the name comes from a spell in the Infocom game Enchanter, and the spell is used to survive unnatural death. We thought that was fitting for an interpreter, which may in some small way help text adventures survive. And it's a multi-platform Z-code interpreter. And we started with this project in 2018. After about 6 months, 5 or 6 months, we had something going which actually worked with some pauses in that time. And then we spent just about as much time optimizing it. So, and then we had the first release at the end of 2018. And so multi-platform. We actually only thought about one platform while developing it, and that was a Commodore 64, because that was a computer that we used when we were kids, and that's what we want to do. And so we said, we saw other people releasing games for the Commodore 64 and even commercial games. We thought, hey, it would be fun to make a text adventure. And like, we've been involved in text adventure stuff for like since the 80s and up to now. I thought maybe we could release a text adventure using like modern tools and release it for the Commodore, and then we'd be doing it as Z-code. And we found that there were no Z-code interpreters that were really free to use for the Commodore 64. So we said, let's start by creating one. And then as time went by, we figured it would be possible and not too hard to port it to +4 and to Commodore 128. We were wrong about the Commodore 128. It was a lot harder than we thought. I mean, just to get it to run wasn't that hard, but if you want to use the features of the 128 to do it justice, then it was a bit more work. +4 was really a walk in the park comparing them. And then the Mega 65, we got some help with the initial port by Gardner, Stephen Gardner, who's the founder of the Mega 65 project, I think, and like the main driving force behind it. And he did an initial port using our source in a day or so, and then we've been refining that and adding stuff to it. Then there's also, and these are all in the same code base that we maintain. And then there's also a port to Acorn BBC computers, which a guy called Steve Flintham has done, which is pretty awesome. Acorn BBC are quite extensible. You can add different kinds of RAM and co-processors and whatnot, and he supports pretty much everything. So that's a cool project too. So the Z machine, it was designed in 1979 by Mark Blank and Joel Beres, who went on to found Infocom. They had written a game on a mainframe at MIT called Zork, sometimes called Dungeon and sometimes Zork. They altered it, and they thought this would be nice to get. Maybe we could sell this to home users, but they don't have mainframe computers. They are starting to get 8-bit computers. By this time, they saw that the Apple II was selling well, and the Commodore PET, and there were others. But it wasn't clear which platform would win. It wasn't clear at all. It was just coming more and more platforms. So they said, if we're going to sell something on this market, we're going to have to make it easy to port the games to or the game. They were really aiming to release Zork. That's what they were doing initially. And we have to make it easy to port it to different computers. So they designed a virtual machine called the Z machine, which is an imaginary computer, much like the Java virtual machine, the JVM. So you write a program for this machine. You'll never run it on the actual machine because it doesn't exist. And but you can write an emulator for this machine for many different platforms. And that's what the Z machine is. With the specification they had, they could pay an external programmer like 1 month of pay and something like that to get a new emulator for a new platform, which was pretty awesome. And then you get a basic emulator of the Z machine for the first version of the Z machine, or yeah, something like that. And what it has a quite compact format. It has text compression built in, so all strings are stored in a compressed format, where the basic part is that each character is reduced to a 5-bit code, and 3 of these characters are stored in each word. And then there are also abbreviations, which makes it even more compact. It has virtual memory, so for the first version of the Z machine, it can handle a game up to 128 kilobyte, running on a computer which needed about 32 kilobyte of RAM to do this, and a disk drive, of course. And this was the first implementation of virtual memory or paging on a microcomputer that we know of. And it was designed to run well on 8-bit machines, which means even today when we're trying to get stuff to get a rather powerful platform to run text adventures, at least on 8-bit machines, this is still a good fit. The specification of the Z machine was reverse engineered in the 90s. And people started building their own interpreters and writing tools that could create Z machine files. The file format for this is called Z code, and an emulator for the Z machine is often called the Z code interpreter. And Ozmoo is one of those emulators. The project goals we had, we wanted to make something that was free to use. It's under GPL2 license. So it should be free to use even for commercial projects. To do this, there could be no legacy code. There should be no code like leftovers from Infocom interpreters, etc. A lot of third-party interpreters have legacy code in them. And we want to avoid that entirely. We wanted it to be fast, so we did spend a lot of time optimizing it. And it is really quite a tricky balance to do for this kind of project, because you do want it fast. It's really important to get it fast because it's hard to emulate a machine on a computer as slow as a Commodore 64. It takes a lot of effort. So you want to do everything you can to make it fast, but at the same time, you have limited memory and you need as much space as you can for virtual memory. So you need to make the code both small and fast. So it's always a compromise. We wanted it to work well on a vanilla Commodore 64 with a disk drive. We also wanted it to work well with modern hardware and RU, both historical Commodore RUs and the modern ones, and SD2 IEC, etc. And we wanted to adhere to the modern Z machine standard as well as possible. Some of the old Infocom interpreters don't, and like in spots here and there, they don't adhere to this modern standard at least. And then when you write a modern game, it can break down a bit when you run it on an old interpreter. Just so you know, I don't see the chat. So if someone wants to shout out, or if there's a question or something, just let me know.
There is a question actually on the graphics.
I was gonna ask, does this run on the C64, or is it an interpreter for the C64 or for PC?
This is an interpreter that runs on a Commodore 64 or a Commodore 128 or a Plus4 or a Mega 65.
That's awesome. Thank you. That's all I wanted to know. Thank you.
Yeah. So the actual program that you download, if you go to our repository and download it, that's a program for Windows or Mac or Linux. Runs on all of them, and you use it to build a disk image, which you then feed into a real Commodore 64 or a Commodore 64 emulator, and the actual code runs there. But so okay, this code, when you download the project, what you do get is a script that bundles the interpreter with a game file, and it produces a disk image, basically.
Now, wouldn't it be a better idea just to have a download for the disk image itself, or put it on csdb.dk?
Well, the disk image is like the game file that you want to bundle it with, and there are thousands of game files. So you pick a game file and you select the options. You can customize like the color scheme. You can customize other stuff, and you can add a loader image, etc. And then you build it.
Now, what would I need? What would I need to build it? Do I build this in Linux, as in make sudo make and then sudo make install, or?
I actually, let me get to that. There's a later frame which will make that a lot clearer. If that's fine.
That's fine. Thank you.
Okay, cool. So what we do, like other core features, we want to fit a lot of text on screen, because like a Commodore 64 only have 1,000 characters on screen. And we've seen like cases where we fit like 20 or 30% more than Infocom's interpreters do. One of the reasons is that we use all 40 columns, which actually makes more of a difference than you might think. It's hard to use the last column, because then you get like a space on the next, like it inserts another line or etc. You get some problems. So Infocom actually always skipped on that and just left the last column empty. We don't. It uses as much RAM as possible, and it uses more than 62 kilobyte on the Commodore 64 for the interpreter, for the stack, for virtual memory, etc. And I think about 120 kilobytes on the Commodore 128. We have named saves. That's another core thing. So you can actually type a name for when you're saving the game, like in the castle or something, and then you remember where you were when you look at your saves. Infocom's interpreters for Commodore 64 never had that. You can have 2 color schemes, and you can customize them fully. So you can have a dark mode and a light mode. That's what we call them, but it's up to the person bundling the game with Ozmoo to choose how to use them. You can add a custom font, and that works on all of these platforms as well. You can customize the cursor. So you can have a blinking cursor or not, and blink it fast or slow, and a different color, and a few other stuff like that. You can have accented characters. You can play games in French, German, Italian, Spanish, etc. And out of the box, we support like 6 languages other than English, but it's not too hard to add your own language to this. But this requires a special font, and we supply fonts which cover all of these languages. But since like the Commodore 64 doesn't have like an A with 2 dots over it like German has, so then we replace some other character, some graphic character with that, and then we map so that there's something that makes sense on the keyboard that produces that character, and we map it for both input and output, and it just ends up working. And then we have a bunch of features that depend on platform. We have different build modes. You can build a small game for a system with a single 1541 drive. Or you could build a bigger game for a system with the dual drives. since it uses virtual memory, if you have a really big game, if you have a game of like 250 kilobyte or something, it will need to access different parts of the game data as you play. And if you have a single drive, you would need to swap the disk a lot. Like that could be a lot, could be several times just to do one turn. So you need a dual disk drive, and it will distribute the data so that everything is accessible at all times to the computer. You can do that. You can use the 1571 drive for Commodore 128, using both sides. You can fit a bit of game. You can use a 1581 drive, or of course, you can do all of this with just disk images. It produces disk images, and it's up to you if you put them on an SD2 IEC memory card, or if you play in an emulator, or if you copy it to a real disk. It works in either case. You can produce a game which it's held in a single file. That can be done on the Commodore 64 and a +4. To do this, the game has to be quite small, and save and restore still requires a disk drive. So it's not fully like tape compatible, but you can put that single file on a tape, and a person who only has a tape drive can load it and play the game, which is still pretty cool. It does support an RU, so if you have an RU for the 64 or 128, it can cache all game data into the RU, and there won't be any pauses to load from the disk drive while playing. If you want to, it will ask you if you want to do it. And it supports Hyper RAM for the Mega 65, which is like much like a big RU. It's 8 megabytes of RAM, which you can access pretty quickly on the Mega 65. And we're using some of that to cache the game data. We're using CPU speed up on the Commodore 128 if you run on in 80 column mode, which is up to you. If you start the game on the 80 column screen, it will run there. And if you start it on the 40 column screen, it will run there. If you run on the 80 column screen, it will switch to 2 megahertz. If you run on the 40 column screen, it will switch to 2 megahertz while the raster line is in the border, which is effectively making it like about 1.3 megahertz machine. The +4 does that automatically. It runs at like almost 0.8 megahertz, and then something like 0.8 megahertz, and then it doubles that while in the border. And for Mega 65, we're running at 40.5 megahertz because that's what you can do there. It supports 80 column screen for the 128, and for the Mega 65, it supports a loader screen showing a graphic image while loading the game for the Commodore 64 and +4. And it has a set of colors. We started with the Commodore 64, so it was natural for us to base it on that. So when setting options for colors, you set it for Commodore 64 colors, and you will get approximation of those colors for all other platforms. So while in theory you could have a lot more different colors on the +4 and the Mega 65, you don't get that by default. You'd need to do a bit of hacking if you want to access the extra colors. But it does make it quite convenient because you can release a game with the same color scheme somewhat. I mean, it could be approximations, but you can pretty much easily build it for 4 different platforms and get the same colors for all. Some implementation details. This is coded entirely in assembler. It's been suggested time and time again to us to just use the C source of some popular Z code interpreter because they're really good ones. But that won't be small enough and it won't be fast enough. The assemble program is about 10 to 12 kilobyte, depending on options. And but typically assembling it ends up something like that. But yeah, and a bunch of the code is different depending on platform and options. We spent several months optimizing it, and we reached twice the speed to play through a game in benchmark mode. We made a benchmark mode which plays through the game hit Hollywood Hijinks by Infocom. And when we started, it could play through it in 30 minutes on Vice with the realistic drive emulation. And when we felt like we were done with the first round of optimization and ready to release the first version of the interpreter, it was down to 15 minutes. Now with an RDU, it's about 10 minutes on a Commodore 64 to play through the game in 450 moves. On the Commodore 64, we typically reach around 2,000 operations per second in the Z machine, which we think is pretty good. And about I'd say almost twice that on the Commodore 128 in 2 megahertz mode. We use Acme cross assembler, which we think is really good, and it works flawlessly across all these platforms. It has perfect support for the Mega 65 processor even. We have a build script in Ruby, which is, I don't know, maybe 2,500 lines or something, and it does pretty complex things in building these disk images, which was really too hard to do in like a normal make script. We use Exomizer for compression. So we store the interpreter together with as much data as possible from the story file, well, the game file, into one file. So when you load it up, you get your memory filled with, the virtual memory is filled with data when you start. So you don't have to wait as much. Because typically you have, a lot of people have a fast loader that kicks in when loading a file, but then you don't have a fast loader when reading raw disk sectors, because that's how we need to store it on most of the platforms. To be able to access any part of the game data, we have to be able to read something which is like 1 or 2 or 3 or 10 or 15 kilobytes into the game file. And if it's stored as a regular file, then we'd have to search through all of the previous sectors or keep an index in memory, etc. And we don't have the room for that. So we store it in raw sectors and just allocate them. That's what Infocom did as well. And it's built to work on Windows and Mac and Linux. And I would say it does. Johan Berntsson and I, who developed it, we work on different platforms. I do all my work on Windows, and he does all his work on Linux. And so we make sure that these keep working. And people have reported it works well on Mac as well. I'm not sure how I'm doing with time. I only have a few slides left.
We are really bad with time, so.
Okay, but I think it's just this and one more slide. So Ozmoo Online, that's a place where you can go if you don't want to install it, if you don't want to go through the hassle of installing it and the dependencies and all. So then you just go to Ozmoo Online. There's a link there, but if you Google Ozmoo, you find it. No problem. It's among the top links you should see there. It has most of the features. There's just a few missing. You get your own file areas. You can upload files. You can upload, download. You can build new disk images, etc. There are some hundreds of users of this. And it comes preloaded with Infocom games and Pune-Inform games. Pune-Inform is a modern library, which Johan and I also designed to write text adventures for Z code format. And they are meant to be small and fast enough to run on 8-bit platforms. And you can upload your own game files that you get from other sources that you built yourself or you download from the internet or something. So just that's a link to the homepage, but as I said, you Google it and you find it, I promise. And if you want to follow what's happening, you should follow me on Twitter. Questions?
Excellent. Thanks, Fredrik. There were some questions, but some people have been answering them in the chat. I don't see more questions at the moment. I don't know if anybody has any question. Just ask it now.
I have a very quick question. Do you think it would be feasible to actually not create an interpreter of the Z code, but compiler? So
Some-
compiling directly to 6502 and not interpreting the Z code, because I understand you are keeping the Z code, byte code or something like that in the memory and interpreting it. Do you think it's feasible to just create a compiler and run directly the 6502?
Sure it is. Problem is a typical game is far too big for the Commodore 64. So when you write a Z code game, you write it typically today. You probably use a language called Inform, which compiles to Z code, and you don't have to care about the target platform. You don't have to know that the target not much anyway. You don't have to know that whether the target platforms has like 32K of RAM or 64K or 128K or whatever. You can just assume that it will have the parts of the program that it needs when it needs it, when it needs them. If you go to a compiled program, then you need to implement virtual memory outside of that somehow. I think that would be a lot harder.
Understood. Yes, I agree.
Yeah.
Thanks.
And the biggest games you can play with this, there are games which approach 500 kilobyte, which run even on the Commodore 64 using this. The formats, the C machine formats, there are versions 1 to 8, and version 6 has extensions for graphics and sound. We don't support that, but we support all other versions. And version 8, which is the biggest version, allows for the biggest games, can support games up to 512 kilobyte. But typically they are more feasible to play on the Mega 65 because it's a much faster computer. And yeah. But it depends on how the game was written. If it's written in a way that's quite efficient, it can work well on even on a Commodore 64, especially with an REU.
Good. Thanks. Thanks, Mike. I will now stop the recording, and I think